through the multi-sim software, so which is used for designing analog as well as digital circuit. So first of all, what is circuit simulation? So electronics have an important place in daily life, so important in fact that the modern world cannot be imagined without electronics. So from reading and writing emails by using mobile phones to call and send text messages, writing a letter, so managing your data in a spreadsheet, everything. So controlling your objects in the traffic, so everything here. So we cannot imagine without electronics. So that electronics has become a part of our human life here. Why we need circuit simulation means, so in order to have the in order to have how the output looks like before going for actual implementation. So for this we require the circuit simulation. Now let us see the multi-sim software. So in the multi-sim software here we have the two things. So one is multi-sim and second one is LT board. So it is developed by the NI here, that is National Instruments Company. So we will go to it. So National Instruments, so we have the NI multi-sim and we have the NI LT board. So NI multi-sim we use it to drag the digital as well as analog circuit and simulate that, and whereas LT board we use it to design the PCBs for the given circuits or for the circuits we have drawn. Okay. So actually, so now click on the NI multi-sim 14.1 version, so which we have installed. Before that, so there are several circuit simulators in the market, but the popular simulator is SPICE simulator. So as I told you in the morning, so SPICE stands for Simulation Program with Integrated Circuit Emphasis. Okay, so this multi-sim software has been developed at University of California at Berkeley. So this simulator is so powerful that commercial simulators are based on it. Okay, so even multisim is based on the SPICE. So of the many simulators available, so multisim has emerged as the best for the circuit simulation. So if you want to give a definition about multisim, so just we can give it as a multisim is a SPICE based simulator produced by National Instruments in Austin, Texas, with a schematic capture interface that allows easy circuit topology input and specification of simulation data. This evaluation version of this multisim can be downloaded from the ni.com. So NI means National Instruments. The importance of multisim is that, so it is used for the circuit analysis that allows the user to observe the behavior of the circuit before the actual manufacturing of the circuit, and next you can use the ideal components to isolate the design and to know the circuit limitations, and we can also make the measurements that are hard to make in the real circuit. For example, in a real circuit, for example, some measurements were difficult to take. Why? Because they may damage the circuit. Okay, maybe it will be affected. It may be affected by the electrical noise. So sometimes there will be a lack of proper measurement equipment. Perform repeated simulation, and also we can perform the repeated simulations with parametric values for a component. So in multisim, we can observe the temperature dependence of the behavior of the circuit, and also we can observe the circuit behavior under parasitic elements due to the real components. So these are the various advantages of multisim. So in one word, what we can say is that multisim is a SPICE based simulator. Okay, so among several simulators, so SPICE is the most important simulator and most powerful simulator. Based on the SPICE, multisim has been developed. Okay, so next you see here, so it is the workspace of the multisim here. So it is the workspace of the multisim. It is, and here it is the instrument toolbar, and here it is the command menu here. So now, in order to have place the components on this workspace, what you can do is that you can right click on the workspace. So if you right click on the workspace, you can get the place component. So in the place probe, place on schematic, place graphic, place comment. So these are the different things where you can place the different schematics or components on the circuit. So now if you click on the place component now, so a window will pop up. So this window is a select a component window here. So in this there are three databases. The first one is master database, second one is corporate database, and third one is user database. So these three databases are provided by default in the multisim. So master database is the database in which a number of components are predefined by the National Instruments company. The company itself has defined various number of components internally with the circuit. Once you install the software, so automatically these components will be available in the software. And next one is user database. So user database means here you have to define a component. For example, you want to define some adder. Okay, so as a component, but if the adder is not available internally in the software, so at this point of time you can define the adder as a symbol, so that you can define whatever you can define that are available in the user database. And next one is corporate database. So in the corporate database, whatever the symbols are defined by the users. Okay, so these are these systems when connected in LAN, so they can be used by the group of members. So it is called as corporate database. So as I told you, three databases are present here: master database, corporate database, and user database. So master database means the list of symbols and schematics predefined by the multisim software. So once you install the software, automatically the data will be present in the software itself. And user database means, so whatever the symbols we doesn't find in the software, so these are defined by the users. So by writing the spice code, these are defined by the users, and these defined components or defined schematics are present in the user database. And next one, the corporate database means, as I told you, for example, in a company there are 10 persons who are using the multisim software, or in an academic institute, so 10 people are using the multisim software. Among that, 6 users have defined their own components. So whenever these systems are connected in LAN, so everyone can use this component. So that database is called as corporate database. And now here, so select the master database. In the group, there are different types of groups in the sources. So if you click on the source, so different power sources, signal voltage sources, and next in the signal voltage sources we have the AC voltage, DC voltage, exponential voltage, step voltage, pulse voltage, thermal noise, triangular noise. Different types of voltages are present in the signal voltage sources. And signal current sources, so different types of current sources are predefined. So like AC current source, bipolar current source, clock current, DC interactive current. There are different types of current sources. So depending upon the requirement, you can choose any of the current source and you can implement in your circuit. So next, current controlled voltage sources, current controlled current sources, and current function blocks, and digital sources. So these are the different types of sources present in the master database. So after that, basic. So in the basics, you have the mainly you have different types of transformers. So and these are the transformer numbers here. So one P2S, one P3S, different types of transformers. And if you click on next, you have the RLCs, you have the resistors. So different types of resistor values and capacitors, inductors, variable capacitors, variable inductors, thermistors. So different types of basic things that are required to design the circuit are present in the basic group. And for example, so I have taken selected the resistor here. So I have selected the resistors again. In the component, I have selected the 1K ohm, that is 1 kilo ohm resistor. So here you can see that the symbol of that, the symbol of the resistor can be seen here. And if you click on the view model, so its model can be seen. How this has been designed can be seen. Similarly, you can see the detailed report of that. Okay. So in the detailed report, so the symbol name, its family, its database, so its family group. So what the power dissipation values, its corresponding spice code. So it is the corresponding spice code here. Okay. So these are the footprints. So footprints means, so whenever we are implementing the PCB design by using this resistor, so on the PCB you get the resistor like this. So these are called as footprint preview. So footprint previews also can be seen. So this is the different types of packages, how the footprints will look like. So you can see here for every component you select. So a detailed report and as well as model can be seen. So again here we have the how the resistor, how it is manufactured. So the resistor, it can be manufactured by using different techniques. So you can use the resistor depending upon your use here. You can select it. Okay. So once the basic is done, so next one diodes. So different types of PN junction diodes, GNOR diodes, photodiodes, LEDs, so are available. So with the different component values. So similarly, you have the transistors. So NPN, BJT, NPN transistors, PNP transistors, Darlington pay transistors. So PMOS transistors, NMOS transistors. So power PMOS and power NMOS transistors, UJTs. So different types of transistors are predefined here. So after that, in the analog, you have the operational amplifier. So operational amplifier means, so it has two inputs here mainly. Okay. So 741, it has two inputs. So it will give the difference of the two different output as the amplification of the differential input signal. And we have the comparator, differential amplifiers, we have wideband amplifiers, audio amplifiers, instrumentation amplifiers. So all these amplifiers are predefined in the analog library. And next one is TTL logic. So here different logic gates are defined here. 7400 is NAND gate. So like that. So different logic gates are predefined here. TTL family means, so transistor logic. These logic gates are made up of TTL logic, and similarly CMOS. So in the CMOS also different types of different types of logic gates are provided. So these logic gates are provided with the help of CMOS technology. So TTL means transistor logic technology. So with the help of BJT they have been developed, and it is with the help of CMOS. So microcontrollers, so you can use the different types of microcontrollers here. So 8051, 8052 and PIC microcontroller, and these are the predefined RAM and ROM here. So the different advanced peripherals. In case of mixed, we have the mixed signal means, so which deals with both analog So here we have the ADCs. So DS, that is analog to digital converters, digital to analog converters. Predefined mixed components are present. So these are the different indicators. So voltmeters, ammeters, probes, buzzer, lamp. So different types of indicators are present. So next one is power. So here different types of switches, power controllers, voltage monitors, voltage regulators are predefined. And then next one, in case of miscellaneous, you have the transconductors, so vacuum tube, filters, transmission lines were predefined in the buck boost converters, buck converters. So these are predefined in the miscellaneous things. And in case of RF and electromechanical, so there are different types of connectors also here. Okay, so these are all defined in the master base. So more than the components are in the multi-sim software. So now place probe. So place probe means if you want to measure a particular at a particular point, if you want to measure a voltage or voltage or your current or power, so you can probe the values. If you place the probe, automatically you can select what you want to measure, voltage or current. So you can place the different types of connectors. If you want to connect one circuit to another circuit, you can use the different types of connectors here. So it is the graphic. If you want to label any node or if you want to draw any lines, or else you can use the place graphic here. So, and if you want to give the comment to your circuit, you can use the place circuit. So again here, now you can see here. So now moreover, so in the edit menu we have, so in the file menu, so we have a normal file, new, open samples, like that. In the edit menu, so here we have the graphic annotations, we have the order, assign layers, so different things are present here. So in the view menu here, so we have the netlist viewer, everything is present. So it is the place so in the simulations here, apply the different types of signals. We have the wattmeter, oscilloscope, Bode plotter, frequency counter, logic analyzers, logic converters, so distortion analyzers, spectrum analyzers. So all these are present in the instrument tab here. Okay, so here and you can do the analysis and simulation. Okay, so the analysis and simulation, what we have present is, here we can go for the DC operating point, we can go for the AC sweep analysis, we can go for the transient analysis, DC sweep analysis, single frequency AC analysis, parameter sweep, noise, Monte Carlo analysis, Fourier transform, temperature sweep. These are the different kinds of analysis what you can do. So now let us analyze a small circuits by using this NI multisim software. So now first what we will do is that, so we will construct a small circuit here. So in order to construct the small circuit here, so what you can do is that, so right click on the workspace. So after right clicking on the workspace here, so click on place component. Okay, so if you click on the place component here, so I will go for a small resistive circuit, so with an independent DC voltage source here. So I will construct a resistive circuit, means the circuit which consists of resistors. Okay, the resistors are present in the basic group. Okay, so select the resistor. and place here. Okay. So similarly, you can again select it, or you can copy it and you can paste it. So you can do anything. You can copy it or you can paste it. So paste here. So if you want to change the orientation, select that, and you can go to the edit orientation and you can rotate it. So next, uh, I am taking one more resistor. Okay. Next, I am taking a independent DC voltage source. So in order to select the DC voltage source again, so again right click component. Okay. So voltage sources are present here. Sources. So I have to take the all the voltage sources. So here go for the DC voltage source. So AC power, AC, DC current. Signal voltage sources directly will go here. Bipolar voltage. So these are the different voltage sources. So FM voltage, exponential voltage, so AM voltage, clock. So now select that particular thing here. So independent DC voltage source. I think DC. Yeah. So before that now. So in order to connect this, okay, so how you can connect means, so if you take your cursor to the end of your resistor, automatically you get the wire and you just give the connection to the other resistor. Okay, so similarly, so now take, so next you require a ground here. So for placing the ground, so again go to components. So place component here. So in the power sources, ground. So similarly in the power sources only you take DC power, so which you require here. So place the independent DC voltage source. So now connect it. So connect the circuit, so as shown. So now I am varying the resistor values. So in order to vary the resistor values here, so this I am keeping it as 1 kilo ohm. So all this, so let it be 1 kilo ohm here. So this, so take it as, so if you in order to change the value, if you double click on this, so automatically you will get the values here. So here, if you want to change the V1 labels, means you can change the label So if you want to change the display settings, means here you can change the display settings. So here change the value to 10. So click on OK. So similarly, if you want to change the value of resistor also, you can double click on the particular component. So where you get the properties of that particular resistor. So based on that, you can change the value. So so this is my circuit. Okay. So next I can do the required amount, the required analysis now. So now let us check here. So I want to do the DC operating point analysis here. Okay. So I want to do the DC operating point analysis. So it is the basic DC analysis. The basic analysis performed by the multisim is the DC operating point analysis. This type of analysis is performed even when a different types of analysis is chosen. So even though we have chosen AC or DC analysis, we can go for the DC operating point analysis. So why do you want to choose the DC operating point analysis means? So this helps to calculate the node voltages and currents to the voltage sources. So where you can calculate your voltages at the nodes here, and also you can calculate the current that is flowing through the different voltage sources. So now after this, just save the circuit. Okay, so I am saving the circuit here. Design DC operating point DCOP. So in order to do this analysis, so click on the simulate button. So in the simulate, so you go to simulate analysis and simulation. So click on simulate and analysis. Here we have to go for the DC operating point. So select the DC operating point here. Here you can see here the different types of variables that are present in the circuit, and here it is the space where we have to select that particular values for that particular at that particular nodes or that particular values. You can see the values. So here I want to see the current at the voltage V1 in the circuit. If you see here, there is only one voltage source. So DC operating point means I can see the current flowing through this voltage source. So select it, add. So automatically it is added to the other box here. And similarly, I want to see the node V2, the voltage at V2 here. So what you can say is that, so here there are mainly 3 nodes here. Okay, so it is ground node which is connected to so this point is 0 node because it is connected to ground, and it is node 1 and it is node 2 here. So that's the reason why I have selected V2. For suppose okay, so V2 and add. Now after that, so what I can do is that, so just click on run. So automatically you get the DC operating analysis here. So the current that is flowing through the voltage 1 is minus 6.667 milliamps, and the voltage at the node V2 is 10 volts. So like this, you can measure the required amount of current or the required amount of voltage at a particular component. So now what you do is that, so now let us measure the current through R1, R2 and R3. So for this, again go to simulate, analysis and simulation. Okay, so here I want to calculate the current flowing through R1, I want to calculate the current flowing through R2 resistor, and again I want to calculate the current flowing through R3, the power dissipation at that is the power that is existing at R1, R2, R3 and at V1, and the voltage at V1. So now run it. So this is the DC operating analysis at all the values of R1 and R1, R2 and R3, and also the current flowing through the different voltage sources. So like this you can calculate the current, power and voltage to the different components in the circuit by using the DC operating point analysis. Okay, and so after this, so now let us see how you can use the different multisim measurement instruments here. Okay, so multisim provides a set of instruments that can be positioned in the circuit diagram to make measurements. So these instruments can be used to measure voltages, currents, resistance, and decibels, among other more advanced measurements that we can overlook into it. Okay, so the basic kind of the basic kind or the first type of measurement instruments we can see are voltmeter and ammeter. So these instruments are available in the indicator icon here. So that is the indicator icon or instrumentation icon here. You can see the different types of instruments here. Okay, so multimeter, function generator, wattmeter. Okay, so oscilloscope, this is the instrumentation icon, instrumentation tab here. And so in order to see the indicator icon, so you can directly again place component. So in the master database you have indicators here. So in the indicators you have different types of things. So for voltmeter, ammeter, probes. First let us see the voltmeter. So voltmeter here means, you can see here there are four types of voltmeters. So voltmeter H, voltmeter HR, voltmeter V, and voltmeter VR. So these voltmeters are used to measure the voltage at a particular node or voltage across particular resistor or capacitor or inductor. Okay, so this voltmeters you can see here. Voltmeter H means the plus sign will be at the left of your instrument here. So voltmeter HR means the plus symbol will be to the right side. Okay, so voltmeter H means the voltmeter is horizontal in shape and the plus symbol is to the left side. Voltmeter HR means the voltmeter is in horizontal shape and the plus symbol is right side and the minus symbol is at the left side. So voltmeter V means the voltmeter reading will be taken vertically. You can see here. So in the H means the nodes or the connecting wires are horizontal. In the voltmeter V, the connecting wires are vertical. Okay. So depending upon the position of the circuit and the requirement in your circuit, you can select any one of the voltmeter. Okay. So in the voltmeter V means, so it is the connections are vertical and the plus is at the left hand side of the voltmeter. Okay, so voltmeter VR means the connections are vertical and the plus is at the bottom side here. So like this you can see it. So now let us see how you can measure the voltage across the resistor by using the voltmeter. So now just have select voltmeter horizontal. So click on OK here. So now place it. Okay. Similarly, I want to measure the voltage across this R2 here. So in order to measure the voltage across the R2 here, so what I can do is that, so I can take the vertical voltmeter. So again go to place component voltmeter. So vertical voltmeter and I place it. Okay. So next close it. So now give the connections here. So I want to measure the voltage across R1 and R2. So now there is no need of any analysis here. So since we have kept the required voltmeters, directly you can run it. So here there is an option of run. So click on run button, or you can click on F5. So click on F5. So 1 minute. So since analysis is there, it is showing the analysis. Okay.
Balu sir,
Straight.
అక్కడ ఓమ్ మీటర్ ఉంది సార్, మీరు దాన్ని వోల్ట్ మీటర్ కన్వర్ట్ చేసుకోండి సార్. దాన్ని డబుల్ క్లిక్ చేయగానే మనకి వోల్ట్ మీటర్ అని వస్తుంది చూడండి.
లేదు ఈ వర్షన్ డిఫరెంట్ ఉంది సార్, నేను చూస్తాను ఒక నిమిషం.
ఓకే సార్.
So meanwhile, let me check. Might be some technical problem here. So meanwhile you can see here. Okay. So in the SPICE simulator here, in the view there is SPICE netlist viewer. So you can go to the SPICE netlist viewer here. So it is the SPICE netlist viewer. So where you can see the SPICE code of our circuit. So the SPICE code of your circuit you can see here. Okay. So whenever if you want to simulate this circuit, so directly what you can do is that, so you can write the SPICE code also directly without using any thing here. Okay. So this is the SPICE code. So next after that you can see the in the reports you can see the bill of materials. So it is the so this is the net list of your circuit. So how the different components in your circuit has been connected. So you can see here. And next, so if you want all this, you can save this. Okay. So next you can see the statistics of your schematic. So what are the different types of components are there, and how number of components, everything can be seen in the schematic, seen in this schematic static report. Okay. So one minute. So let me check here the value. So it is a DC here. Okay, look, there might be some tool I have installed. So I will go through the different things now. Okay, so I will show it to you tomorrow. So that some technical problem with the tool. And next thing is, okay, so now I can look into the different types of analysis here. Different types of analysis. So there are some predefined circuits here. Okay, so let us see that. So now I'm going for the Monte Carlo analysis. Okay, so I have opened the Monte Carlo analysis. Now, if I run that Monte Carlo analysis, okay, you can see here. Okay, you can see here. So it is simulated for 10 times. Okay, so whenever you have simulated, it is a simple RLC circuit here. So when this RLC circuit is simulated with respect to time, so that means it is done the Monte Carlo analysis with respect to the transient analysis. As I told you in the morning, so Monte Carlo analysis means whenever you simulate a circuit, you get the values, but if you run for the second time, there will be little change in the values. Why? Because the softwares are written with respect to different algorithms. So whenever you run the software due to the internal programming, Java programming or TCL programming, so you may not get the same result at all the time. Okay, so the result will be varying. So now you can see here the output of this RLC is different. So up to 0.4 microsecond you are getting the same output. From there onwards here, so for each run you are getting the different value here. So for 46 here also they have gone for the parametric analysis here. For the they have got the different values here for resistance values of 46, 51, 46, 45. When they run this, so now look at the circuit here. Yeah. So even though you have given the R1 value as 50, so you are not getting the same value of resistance here, but it is taking the different value of resistances. So when you run for the different simulation runtimes, so this is the Monte Carlo analysis. So what does the Monte Carlo analysis is do that? It takes the average value of all this. Okay. So even though the resistor value is 50, so you can see here the variation resistor values at each run. Okay. So the average value is 50. So like that, you can do the Monte Carlo analysis for different types of circuits. And similarly, you can go for the low pass filter here. So it is the low pass filter circuit. So predefined circuit what we have. So and if you run this, so run this. So you can see it. Okay, so you can see it in the analysis or you can see it in the oscilloscope here. Okay, so now if you go for the analysis here, you can see in the analysis tab. So I think it might gone for the AC sweep analysis. Okay, so in the AC sweep, so output variables here. So what are the output variables we require? So V in and V out. So run it. So I can see the AC analysis here. Okay, so low pass filter means so it will pass the low frequency signals and attenuates the high frequency signals. So depending upon the design values, you can set the cutoff frequency. Okay. So these are the different kinds of analysis what you can do, and more so after that. So now just remove this. So now you run this circuit. This one problem. Okay. So we will see it tomorrow. And so after that here, in order to have the different things here, if you want to transfer this spice, you can go to the export netlist also to other tools. So if you use the option of export spice netlist, you can go for the exporting of this spice code generated to the various tools. Now if you want to transfer this circuit as a design, this circuit as a PCB design, So you have to go for the transfer to multi-board. Okay, so transfer to multi-board. So before transferring the circuit to multi-board here, so in the PCB design, so we cannot use the voltage sources. So remove the voltage sources and go for it. Transfer to multi-board. So you save the particular value. So in the documents or in the desktop, I am showing it as DCOP. So now what you can do is that, so you can open the multi-board. So take any name. So in multi-board here, so mechanical CAD or PCB designing. So we are going for the PCB designing. So what you can do is that, so you can directly import. So this on the day 5 you can see about the software in particular. So in the transfer back connect towards the multi-sim. So what back connect towards the multi-sim means, if you are designing a PCB circuit, so directly you can run that back from the PCB, you can go back as the circuit. So these are the different things what you can see here. Okay, so now mostly import the file. Okay, so this file has not been exported. We will take another circuit here. So what you can do is that that is the problem with the export. So because the footprints were not taken, yeah. So before that, here there is circuit wizard here. Okay. So now you click on that circuit wizard. So automatically you can build the circuit here. 555 timing wizard. So these circuits can be taken to the taken to the multi board. So now remove this. So now you can transfer to multi board, I think so. So automatically now you can see here. So how the they have been transferred to multi-board. So these are the components of the circuit where you have designed the circuits, and now these are transferred to the multi-board here. So now what you can do is that you select all this and you have to give the connection. So I'm going just in order to show you, just I'm going for the auto route option. So auto route, so it is automatically routed. So before that, what you can do is that you bring all this within the space here. So within the workspace, now you do the auto routing. Start auto route. Yeah. So it is the PCB how we have designed. So it is the capacitor C2, circular capacitor they have taken in the design, capacitor C1, so R resistor R1, R2, R3. So it is how a small PCB is designed. Now if you want to print that PCB here, that is the circuit board, so you can directly go to it as export in terms of the Gerber files here, so which you can see later the day 5. So next, so far we have seen how to design the circuits by using the master database. Suppose if you want to create the things, for example, if you want to design in a user database here. So what you can do is the component wizard. So in the component wizard, suppose for example a circuit doesn't, if this component is, it does not present in the master database. So what you can do is that, so you can use the component, you can define the component by using the spice code. Okay, component name ASDF. So name of the author you can give here. So if you want the component to be a part of simulation as well as layout, so you can use the simulation and layout. For simulation only means you can use the simulation only. For layout or for the PCB design. Okay, so simulation layout. So type of component, whether it is digital or analog. So if it is analog, it will take the same thing. If it is digital, it will ask for whether it is TTL or CMOS. Just I will show you a small thing. Here, package type. So whether it is a generic package or a package from any one of the companies. Okay, so it's a generic package. So it is not inclined to any company. So number of pins it has. So the component has number of pins. For example, the component has 4 pins. Okay, so 4 pins. So package type. So give the any type of package type. So next. Okay, multi-board footprints. If you want to view, you can view the multi-board footprints. So this is the type of packaging, whether surface mount or through-hole packaging. So no need about this. So click on OK. So it is the pins. So 1, 2, 3, 4. How the pins for that particular IC. Okay. So like this you can design it. Okay. So after that, so it will ask you whether the pins are bidirectional pins or unidirectional pins. You can show here. So whether they are inputs or bidirectional inputs or passive or ground or power. So you can define anything. And define the ICs also here. Okay, so just I am keeping it as it is. So after that here you can give the symbol, pin names, etc., pin numbers. So after that here you can write the model data, how the model number, everything for that your pin. So after that, yeah. So from the resistor, I have taken this model data. So after that, you can mapping table. So the relation between the inputs and outputs. So after that, so you can directly stored in the user database. So like this, you can create the symbol. The creation of the symbol is very difficult and it not required at the academic level. So this is the basics of the multi-sim. In the tomorrow's class, what you will do is that, so we will discuss, so how we will take some RLC circuit. So by using that RLC circuit, we will try to go for the AC analysis, DC analysis, transient analysis, and how to use the Bode plots. Okay, how to use the spectrum analyzer. Everything we will see tomorrow morning. So after that, it is followed by the spice coding. Okay, how to write the spice coding and how to simulate the spice coding. Okay, so tomorrow we can see that. Okay, so if there are any queries, means you can ask me.